So if you want to make your own method or modify one, you're going to open up Excalibur. Instead of going to sequence setup like you would run a sequence, you're going to go to instrument setup, because now you're going to change how it runs the instrument. This is going to bring up you can set up the auto sampler techniques or the auto sampler settings. I wouldn't mess with that. What you really want to set up is the GC. You can see the main window here is the oven. That's going to be really important. That's going to be the main thing that you change in this process. There's also these splitless at the inlet. You can mess with that. The carrier gas, you want to make sure that that's set correctly. The FID, and then there's the run table. You are probably not going to do anything with the run table. Most of these other things, the carrier, the FID, and the inlet, you're just going to make sure that they're set reasonably. The oven is going to have a drastic effect on your data, and you're going to change it a lot. So you can see here right now we're starting at 40 degrees. I'm going to change it to 70 degrees. And I'm going to say, okay, I want you to start at 70 degrees, hold for 5 minutes, and then increase the temperature up to 250 degrees at a rate of 10 degrees C per minute. I'm going to say after you've reached 250 degrees, hold for 10 minutes. Right? I like to go fast. You can see right now it's a 28-minute runtime. If I increase that to 30 degrees per minute, now the runtime is 16 minutes. This is a 16-minute run. So to recap here, if we look at this entire method we've created, and they're showing it as a visual plot of temperature on the temperature on the y-axis and time on the x-axis in minutes, we've created a starting hold temperature and one ramp. So we start at 70 degrees C, hold for 5 minutes, increase to 250 degrees at a rate of 30 degrees C per minute. And when we reach the final run temperature of 250 degrees, then we hold that temperature for 5 minutes. So you can see that visualized up in the plot, and you can also see that written down below. The total runtime here, which we can see next to oven runtime, is 16 minutes. So this run is going to go for 16 minutes. This is a slightly different ramp. You can see similar idea but slightly different hold times. But I want to show you here, if you change the ramps, now I have no ramp. I'm just running 70 degrees for 2 minutes. That's the whole GC run. That's called isothermal. So now I'm going to make an isothermal, the same temperature, where I run at 200 degrees C for 5 minutes. I can also add back a ramp, and this is what I was doing before, start at 70 and go up to 270. But I can also add multiple ramps, and this is going to be handy when you program in the Clarks, because they're going to go from one temperature, ramp up to another temperature, and then ramp up to a third temperature at a different rate. So you can really go nuts with this and add all kinds of ramps and do all kinds of perturbations here. You just push those little up and down arrows, and you're programming in the temperature, if there's a hold time, and how long. Now there's other things I mentioned, the splitless. First of all, you want to make sure that temperature box is checked and the temperature is reasonable. 200 to 300 is reasonable. You want to make sure the split flow is good as well. Alright, the carrier, this is important. This should already be set in the default method, but you need to make sure that the mode is constant flow, not constant pressure, and set your flow here. Your flow is typically going to be 1 mil per minute, 1.0, but you can get away with 1.5. Now the FID, this is really important. The detector has to be on for it to see anything, and it has to be at a reasonable temperature. So 200 to 300 is a reasonable temperature. I'm going to put 250 in here. It's a good idea to have the flame out retry on there. Again, you're not really going to use the run table much, but these other settings besides the oven, just make sure that they're set reasonably and that there's nothing wacky about them. You can also change the split flow. That's something that you can change if you want to try and get bigger peaks or change your peak shape a little bit. I think a split ratio between 20 and 50 is pretty good. Alright, so those are pretty much all your methods. Make sure that you save your method, you save as, so you don't overwrite your example method. You can open up and use the example method that I gave you and then work from there on your Clark's method and your faster method. And again, make sure that everything is saved into your folder.